Then how about this problem that you have minimum degree at least 2, then the graph must contain a cycle of length at least delta plus 1. Okay, plus 1 absolute marks for anyone who does it in next 60 seconds or so. Okay, you just need to argue, okay, and give me the answer. So you have a graph. उसके अंदर you need to show that the graph contains a cycle of length at least delta plus 2, assuming that minimum degree is at least 2. Okay. See that if minimum degree is not at least 2, the graph may not contain a cycle, right? It can be a tree. So ये वाली condition तो important है to have a cycle, that its minimum degree must be at least 2. But now you need to show that there is a cycle, or it must have a length minimum degree plus 1. So you have a vertex vi, and this guy has at least delta outgoing edges. Okay. But this guy also has at least delta outgoing edges.
Sir, minimum number of vertices तो 3 होंगे अगर minimum degree at least 2 है.
Okay, yeah.
तो अगर 2 डिग्री है minimum vertices अगर minimum 3 हैं तो अगर एक उससे हम उस पे हम prove कर सकते हैं easily कि cycle length at least 3 होगी.
Okay, that's true. So if we have a minimum degree is equal to 2, उस केस में हमें ये पता है कि there must be 2 outgoing edges. Actually, let's just do this case. Okay, so here's the case. Quite simple. That delta is equal to 2, and you need to show that there exists a cycle of length.
Sir,
at
I
least
have a
3.
solution. Can I?
Who is it? ऐसा?
Yeah.
चलो बताओ. For this
Sir, I
case
was
or
just thinking,
the whole case?
it's just a simple proposition. I think it's not a whole solution, but I was just thinking, if we have a minimum number of degrees, then to get the minimum length of cycle, we should have the minimum number of vertices too. So we should always have consider that case. Because if we have more vertices, then we obviously have a greater length. So
Yeah.
Sir, wouldn't be minimum number of vertices wouldn't be 3?
So इस case में minimum number of vertices would be at least 3. I agree. So this guy has 2 neighbors. एक ये खुद है और 2 इसके neighbors हैं. So minimum number of vertices is at least 3. I agree.
And when each of them have at least minimum degree of 2, then we
Yeah.
can prove that there is a cycle length of 3 in 3
Yeah.
vertices.
So either they are connected to each other, which case we find the cycle of length 3, or they are connected to someone else. Okay.
In which case it's also proven.
Yeah. So so the thing is, what you could do is you can go to a vertex, and then you can go to another unvisited vertices and keep going. Since this guy has degree at least 2, इसका कोई एक और neighbor होगा. Okay, if this neighbor is one of the nodes जो मैंने पहले से visit किया, I found a cycle. Okay, और ये इस cycle की length at least 3 होगी. तो I am इस ये वाला जो केस है, this is not that hard. It seems कि हमने इसको कर लिया है. Okay, you start an arbitrary vertex of degree at least delta. Okay, you go to one of its vertices. Let's call it I don't know, what do you want to call it? Let me call it v1. Okay, v1 has a neighbor. Let's call it v2. Okay, v1 must have a neighbor which is different from vi. Okay, because v1 has degree 2. एक तो इसका नंबर vi हो गया, तो इसका मतलब ये है कि इसका कोई एक नेबर है जो vi नहीं है, which is v2. Now v2 must have a neighbor because degree of v2 is at least 2, but this neighbor can be vi. If this neighbor is vi, we found a cycle of length 3. Okay, so but if it's not vi, we can go to a new neighbor which is v3. V3 must have a neighbor. Okay, if it's vi, we are done. If it's not vi, then it must be some other vertex, v4. And we keep going. Since there are finite number of vertices, it must hit back to some vertex, either vi or it could be one of these vertices जो यहाँ पे है. Okay, but it must be different from v3 because v4 has 2 neighbors. One of them could be v3, but there must be a neighbor which is not v3. Okay, so this implies that we can find a triangle. Okay, so this case is sort of not that hard. Okay, how about this case? Minimum degree is 3. You need to find a cycle of length at least 3. How do you solve this? The argument is almost the same.
So don't we have to find a cycle of length at least 4, delta plus 1?
Yeah. We have to find a cycle which is at least this big.
So we can just simply say that given any delta, matlab any minimum number of degree, the number of vertices is at least delta plus 1 for any graph. So that I think is proof in itself.
Oh, no. So again, can you repeat?
I said if we have a minimum known degree of a graph, we can say that at least delta plus 1 vertices exist in that graph.
Yes, but it's not implied कि वो the graph connected होगा. ये तो कहीं नहीं लिखा हुआ है ना? है यहाँ पे?
नहीं, but if
so there are 4 vertices in this graph, right?
Yeah.
How do we know that there is a length of there's a cycle of length 4? So I agree. This implies that there are 4 vertices, but how does this imply that there is a cycle of length 4?
So using the same argument we use for delta 2, I think that works.
So we have these 3 vertices in the neighborhood of vi. Then what? So let's say v1 is one of the neighbors. Then what do we do?
Then we can say that it has 2 more neighbors and it must not be one of the other neighbors of vi.
Yes, I agree. That I am fine with. v1 has 2 neighbors which are not vi. So let's call them v2 and v3. Then what?
So now v2 and v3 also have 2 more neighbors, and they
v2,
must.
अब यहाँ पे this is the critical part. अभी इसी point पे आपने एक argument देना है which will complete the proof. Let's forget about v3. I think v3 को use करने का कोई फायदा नहीं है. But there is something we can say about v2 which is really interesting.
So V2 has to have two more neighbors, and then those two neighbors should have more two neighbors. And since we have a finite number of vertices, so we have to revisit some uh, previously visited vertex. So there will be a cycle like this.
Yeah, I agree with you. You are almost through. But there is one critical bit of information missing, जो हमने अभी इस point पे कहनी है. V2 has, by this information, V2 has three neighbors, at least three neighbors. And
V2 VI से कनेक्टेड हो सकता है.
so the critical bit जो मैं अब आपको convey करना चाह रहा हूँ वो ये है कि of the three neighbors जो V2 के हैं, I know that there is one of them which is not equal to V1 and Vi. Okay, there is a neighbor of V2. I don't know where it is and what's its name, but it's different from Vi and V1. Okay, because V2 has three neighbors, right? तो इसका मतलब ये है कि मैं इन दोनों को इग्नोर कर सकता हूँ क्योंकि इन दोनों के अलावा भी एक नेबर है V2 का. Does that make sense? Sorry guys. This is the critical information जो मेरे ख्याल में हमें आगे लेके जाएगी. Okay, and we can say the same thing about V3, that V3 has three neighbors. One of them is different from V2 and V1. So we are creating a path on, let's call it P, on path P. Every next vertex has a neighbor which is different from previous delta minus 1 neighbors. That is the critical part जो हमने use करना है. Okay, V3 का जो neighbor है, it's different from V1 and V2. It can be Vi. Vi now there is a possibility that V3 is connected to Vi. Okay, लेकिन V2 के लिए हमें पता था कि it's not Vi. There is a guy which is distinct from V1 and Vi. Okay, so in general हम क्या करेंगे? We'll start an arbitrary vertex. Let's call it V1. Okay, we'll keep going, and we know that we will keep going for at least delta plus 1, because for each of these vertices there is a guy which is different from the previous guy, because there are enough degree of this guy. Okay, for any Vi the degree is delta, which means कि अगर यहाँ पे इसके पाथ में डेल्टा से कम लोग हैं तो फिर एक होगा जो इससे आगे हमें मिलेगा. Okay, which means we can continue this thread for at least delta plus 1 vertices. Okay, and वो वाला argument ने तो आपने बिल्कुल सही कहा कि this can't continue infinitely. Okay, because there are not infinite vertices, which means that at some point I'll have to come back. But I have to come back to a vertex which is different from these middle delta minus 1 vertices. Does it make sense? देखो यहाँ पे ये वाली बात सबसे इम्पोर्टेंट थी कि मैं Vi का एक ऐसा नेबर फाइंड करूँ जो V1 का एक ऐसा नेबर फाइंड करूँ जो V1 नहीं है, Vi नहीं है. Okay, जिस वर्टेक्स से मैंने स्टार्ट किया था. Let's call it V0. Okay, V1 का मैंने ऐसा नेबर फाइंड करना है जो V0 नहीं है. Okay, similarly in the case of 3 मैंने V1 का एक नेबर फाइंड किया जो V0 नहीं है. फिर मैंने V2 का एक नेबर फाइंड किया जो V1 भी नहीं है और V0 भी नहीं है. Okay, and I can do it because I have enough leverage. I know that V2 has three neighbors. Okay, if they are V0 and V1, but there must be someone who is not V0 and V1. Okay, so that's the critical part for the general case. Okay, for every vertex, I can find a neighbor which is different from the previous delta minus 1 neighbors. Delta minus 1 vertices on the path. Okay, this will help me find a path of length delta plus 1. Is it clear? Do you understand the main part?
Yes, sir.
Okay, great. So the information that that we can continue is fine. वो हमें मिलेगी because हमारे पास इतनी डिग्री है. But कि हम साइकिल जो क्रिएट कर रहे हैं उसकी लेंथ एटलीस्ट जितनी होगी, उसके लिए ज़रूरी है कि we meet a vertex which is not in the previous delta minus 1 vertices. Okay. Awesome. Okay. Okay. उबैद एसन को तो मेरे ख्याल में 0.5 मार्क्स दे दो यार इसमें से हैं. He did not say what I wanted him to say, but he was in the vicinity of the original argument.